साथियों नमस्कार। फिर हाजिर हूँ आपके साथ मेजर ऑफ वेरिएशन लेकर। वेरिएशन variability is essential in normal character. The occurrence of variability is a biological phenomena. It is an important characteristic indicating the extent to which observation vary among themselves. There are three types of variability: biological variability, real variability, and experimental variability. Measures of variability. Variability and its measurement are of fundamental importance in the biological sciences. The variability of a given set of observation will be zero only when observations are equal. It takes positive when observations are unequal. It helps us to find out how individual observations are dispersed around the mean of a large series. They may also be called measures of dispersion and variation, etc. Dispersion. The measure of dispersion is designed to state numerically the extent to which individual observations vary on the average. Measure of dispersion. Absolute measures and relative measures. Absolute measures are range, quartile deviation, mean deviation, and standard deviation. Relative measures are coefficient of variation, coefficient of quartile variation, coefficient of mean variation. I will repeat it once again. Measures of dispersions are of two types. First is absolute variation measures. Absolute measures are range, quartile deviation, mean deviation, and standard deviation. Relative measures or measure of dispersion are coefficient of variation, coefficient of quartile deviation, coefficient of mean deviation. Absolute measures, which are range, quartile deviation, mean deviation, standard deviation. Absolute measure of dispersion. These are expressed in same statistical unit in which the original data are given. The values may be used to compare the variation in two sets of observation provided the variables are expressed in the same unit and of the same average size. Again, when two sets of data given in dissimilar units, the absolute measures or dispersions are not comparable. Relative measures of dispersion. It is the ratio of measure of absolute dispersion to an appropriate measure of central value and is expressed as pure number. These are independent of the units of measurement. Relative measures may also be used to compare the relative accuracy of data. Measures of dispersion. Dispersion is the measure of the variation of the items. In other words, measurement of the scatteredness of the mass of figures in a series about an average is called measure of variation or dispersal. Significance of measuring dispersion to determine the reliability of an average. To serve as a basis for control of the variability. To compose two or more series with regard to the variability. To facilitate the use of other statistical measures. Methods of studying dispersion. The following are the important methods studying the variation: the range, the interquartile deviation and the quartile deviation, the mean deviation, the standard deviation, and variance. First, the range. The range is the simplest method of studying dispersion. It is defined as the difference between the values of the smallest item and the values of the largest item included in the distribution symbolically. Range into L minus S, where L is the largest item and S is the smallest item. The relative measure corresponding to the range, called the coefficient of the range, is called obtained by applying the following formula: coefficient of range into L minus S upon L plus S. Coefficient of range is equal to L minus S upon L plus S if the average of the two distributions are about the same. A comparison of the range indicates that the distribution with the smaller range has less dispersion and the average of that distribution is more typical of the group. calculate the range of its coefficient of the following observation: marks 10, 20, number of student 8, 20, 30, number of student 10, 30 to 40, number of student 12, 40 to 50, number of student 8, and 50 to 60, number of student 4. The range is equal to L minus L. The lowest limit is 10 and highest limit is 60. So value of the L is 10 and value of S is 10 and L is 60. The range is equal to L 60 minus S 10. So 60 minus 10 is equal to 50. Coefficient of range 60 minus 10 upon 60 plus 10, 50 upon 70 or 0.714 is the coefficient of range. Merit and limitation. Amongst all the methods of studying dispersion, range is the simplest and to understand the easiest to compute. It takes minimum time to calculate the value of range. Hence, if one is interested in getting a quick rather than a very accurate picture of the variability, one may compute range. Limitation. Range is not based on each and every item of the distribution. It is subject to fluctuation of the considerable magnitude from simple to simple. Range cannot be tell us anything about the character of the distribution within the two extreme observations. Range cannot be computed in case of open-end distribution. Interquartile range and quartile deviation. Interquartile range can be defined as range which includes the middle 50% of the distribution. Range which includes the middle 50% of the distribution, that is 1/4 of the observation at the lower end and another quarter of the observation at the upper end of the distribution, are excluded in computing the interquartile range. In other words, interquartile range represents the difference between the third quartile and first quartile symbolically. Interquartile range is equal to Q3 minus Q1. Very often, the interquartile range is reduced to form of the semi-interquartile range and quartile deviation by dividing by 2 symbolically. Interquartile deviation is equal to Q3 minus Q1 upon 2. Quartile division gives the average about by which quartile differs from the median. In asymmetrical distribution, two quartiles Q1 and Q3 are equidistant from the median as such that differences can be taken as measures of dispersion. The median plus minus quantile deviation covers exactly 50% of the observation. In really, however, one seldom finds a series on the business and economic data that is perfectly symmetrical. Near all the distribution of the social series are asymmetrical. In asymmetrical distribution, Q1 and Q3 are not equidistant from the median. Quartile division is an absolute measure of dispersion. The relative measures corresponding to this measure, called the coefficient of quartile division, is calculated as follows. Coefficient of quartile division is equal to Q3 minus Q1 upon 2 upon Q3 plus Q1 upon 2 is equal to Q3 minus Q1 upon Q3 plus Q1. Coefficient of quartile division can be used to compare the degree of variation in different distribution. Computation of quartile deviation. The process of computing quartile deviation is very simple. We have just to compute the values of the upper and lower quartile, find out the quartile deviation and its coefficient from following data. Roll number 1, 2, 3, 4, 5, 6, 7. Marks 20, 28, 40, 12, 30, 15 and 50. Marks arranged in ascending order. It will become 12, then 15, then 20, 28, 30, 40 and 50. Q1 size of n plus 1th quartile upon 4. N plus 1, the size of total the number 7. So 7 plus 1 upon 4 is equal to second item. The second item is 15. Thus Q1 is 15. Q3 size of 3 n plus 1 upon 4th item. Size of 3 upon 4th, 3 multiplied by 8 upon 4th item is equal to 6th item. Arthya choice चलो मुझे 4 छंग चॉइस, 6 बार चलेगा, 6th आइटम आएगा. Size of 6th item 1, 2, 3, 4, 5, 6 is 40. Then Q3 is 40. Thus QD is equal to Q3 minus Q1. 40 minus 15 upon 2 is equal to 12.5 is quartile division. QD is 12.5. Coefficient of quartile division Q3 minus Q1 and Q3 plus Q1. Q3 40 minus Q1 15 upon Q3 40 plus Q1 15. The 14 minus 15, 14 plus 15 is equal to 25 upon 55 is equal to 0.455. This is the coefficient of quartile division. You have to remember this formula n plus 1.4 so that we can calculate Q1. So 7 plus n 4 is equal to second item aa gaya. In next exercise, the Q3 is the size of 3 multiply n plus 1.4. So size of 3 multiplied by 8 upon 4th is equal to 6th item आएगा. तो ये इस प्रकार क्वारंटाइल डिवीजन और कोफिशिएंट ऑफ क्वारंटाइल डिवीजन को हम ज्ञात करते हैं. इसके मेरिट्स और डिमेरिट्स देखें. It certain respect its superior to range as a measure of dispersion. It has special utility in measuring variation in case of open and distribution or one in which the data may be ranked but measured quantitatively. It is also useful in erratic or badly skewed distribution where the other measure of dispersion would be wrapped by extreme values. Quartile division is not affected by the presence of extreme values. Limitations. Quartile division ignores 50% item, either first 25% and the last 25%, as the value of quartile division does not depend upon every item of the series. It cannot be regarded as a good method of measuring dispersion. It is not capable of mathematical manipulation. Its value is very much affected by simple fluctuation. It is in fact not a measure of dispersion, as it really does not show the scatter around an average but rather a distance on a scale. Quartile division is not itself measured from an average, but it is a positional average. Mean deviation. Mean deviation is also known as average deviation. It is average difference between the item in a distribution and the median or mean of that series. Therefore, there is an average in taking the deviations from median because the sum of deviation of items from median is minimum when signs are ignored. However, in practice, arithmetic means is more frequently used in calculating the value of average deviation. This is the reason why it is more commonly called as mean deviation. Mean deviation is equal to 1 upon capital N sigma x minus x bar. N represents the number of observation, x bar represents the distribution, or x represents the observation. Relative measure corresponding to the mean deviation, called the coefficient of mean deviation, is obtained by dividing mean deviation by the particular average used in computing mean deviation. Thus, if the mean deviation has computed from median, the coefficient of the mean deviation shall be obtained by dividing mean deviation by median. Coefficient of mean deviation is equal to mean deviation upon median. Merits and limitation. It is based on each and every item of data. Consequently, change in the value of any item would change the value of the mean deviation. Mean deviation is less affected by value of extreme items than the standard deviation. Since deviations are taken from a central value, comparison about formation of difference distribution can easily be made. Limitations. The methods may not give us very accurate results. Reason is that mean deviation gives us best result when deviations are taken from median. It is not capable of further algebraic treatment. It is really used in sociological studies. Next one is standard deviation. Standard deviation concept was introduced by Carl Pearson in 1823. It is by far the most important and widely used measure of studying dispersion. Standard deviation is also as root mean square division. Root mean square division for the reason that it is the square root of the mean of the standard deviation from the arithmetic mean. Standard deviation is denoted by small Greek letter sigma. Sigma is equal to root sigma x square upon n. Sigma is equal to under root sigma x square upon capital N. Small x is equal to capital X minus x bar. X is observation of the variable value. X bar is the arithmetic mean of the population. N is total number of observation. Merit, it is the best measure of dispersion because it possesses almost all the requisite of a good measure dispersion. It is the best on all observation. If one of the observation is changed, SD also changes. SD is least affected by fluctuation of sampling. A small standard deviation means a high degree of uniformity of the observation as well as homogeneity of the distribution. On the other hand, a large SD standard deviation means just opposite. Hence, standard deviation is extremely useful in judging the representation mass of the means. When number of observations are less than 30, sigma is equal to root sigma x square 1 n minus 1. जब प्रेक्षणों की संख्या 30 से कम होती है तो ये फॉर्मूला हम काम में लेते हैं स्टैंडर्ड डेविएशन के लिए. सिग्मा इज इक्वल टू रूट सिग्मा एक्स स्क्वायर अपॉन n minus 1. Now we come to the standard error. The standard error SC is standard deviation of the sampling distribution of statistics. Standard error is standard deviation of sampling distribution of a statistic. The term may also be used to refer an estimate of the standard deviation derived from particular sample used to compute the estimate. Standard error is equal to standard deviation upon root n is equal to sigma upon root n. As the standard deviation and the size is equal to sample. Difference between mean deviation and standard deviation. Both of these measures of dispersion are based on each and every item of the distribution, but they differ in the following respect. Algebraic signs are ignored while calculating mean deviation, whereas in the calculation of standard deviation are taken into the account. Mean deviation can be computed either from median or mean. Standard deviation, on the other hand, is always computed from arithmetic mean because the sum of the squares of the division of the items from algebraic mean is the least. Variance. Variance of a distribution divided by the square of standard deviation. Thus, variance is to SD का whole square. Variance is equal to sigma square. Variance is equal to 2D or F. DF is equal to degree of freedom. It can also be calculated in two ways. When the data sets are separated, when the data sets combined. How to calculate combined variance of data sets? There are 4 conditions for measuring combined variance. In the sample is sum for all observation. X1 is equal to X2 bar is equal to X3 bar is equal to Xn bar. Then sigma square is equal to N1 sigma 1 square plus N2 sigma 2 square plus Nn sigma n square upon N1 plus N2 plus N3 plus Nn. A number of observation is same for all sets. Sigma square तो sigma 1 का square plus sigma 2 का square upon 2 is 1.4 x1 bar minus x2 bar का whole square. If number of observation standard deviation are equal for all sets, n1 is equal to n2 and sigma 1 is equal to sigma 2, then sigma square is equal to sigma 1 का square plus 1.4 in bracket x1 bar minus x2 bar का whole square. In class 4, n1 is equal to n2, sigma 1 is equal to sigma 2 is equal to 0, then sigma square is equal to 1.4 x1 bar minus x2 bar का bracket का whole square. Coefficient of variation CV. Standard deviation is the absolute measure of dispersion. Corresponding relative is known as coefficient of variance, and it is used such as problem where we want to compare the variability of the more than two series. Coefficient of variance is denoted by CV, is calculated as CV. Coefficient of variance is equal to SD upon AM into 100. SD upon AM into 100. Variance is also useful measuring dispersal of population. Population dispersion is equal to variance upon mean S square upon X bar. Covariance sigma in bracket X minus X bar multiplied by in bracket Y minus Y bar upon capital N का square. Covariance is the measure of how two random variables change together. The sign of covariance therefore show the tendency of linear relationship B upon W, the variance it may be positive or negative. Positive if the greater the value of one variable mainly correspond the greater value of other variable to the same holds for smaller variable tends to show the similar behavior, the covariance is true. Negative, the greater value of one variable tend to show opposite behavior, the covariance is negative. This is all about the measure of variance. The formula repeated again. Variability is essential for normal character. Occurrence of variability biological phenomena. It is important characteristic indicate the extent to which observation vary among them. There are three types: biological variability, real variability, experimental variability. Dispersion, measures of dispersion, absolute measures, range, quartile deviation, mean deviation, standard deviation, relative measures, coefficient of variation, coefficient of quartile deviation, coefficient of mean variation. Range L minus L, L largest and S smallest, coefficient of L minus N upon L plus S. Very simple. Now next, the interquartile range, quartile division, interquartile range Q3 minus Q1 and quartile division Q3 minus Q1 upon 2. Coefficient or QD, Q3 minus Q1 upon 2, Q3 plus Q1 upon 2 is equal to Q3 minus Q1 upon Q3 plus Q1. This is quartile division. Very easy. And next is mean deviation. Mean deviation 1 upon capital N sigma in bracket x minus x bar bracket close. Mean deviation MD is equal to 1 upon N sigma x minus x bar. Coefficient of mean deviation upon median is coefficient of mean deviation. Standard deviation sigma is root sigma x square upon capital N. This is standard deviation. Sigma when observation are less than 30 to sigma is equal to root sigma x square upon capital N minus 1. Standard error is equal to standard deviation upon root n, sigma upon root n is the standard error. Variance is equal to standard deviation का square, variance is equal to sigma square, variance का degree of freedom 2, V is equal to 2 degree of freedom. Thank you for watching this video. Covariance, population dispersal, variance upon mean. यहाँ वेरियंस का स्क्वायर दे रखा है, वेरियंस का स्क्वायर अपॉन मीन एस स्क्वायर अपॉन सीवी. याद रखना सीवी इज इक्वल टू एस डी अपॉन ए एम इंटू 100. सीवी इज इक्वल एस डी अपॉन ए एम इंटू 100. कोवेरियंस सिग्मा एक्स माइनस एक्स बार वाई माइनस वाई बार अपॉन एन स्क्वायर. Positive and negative covariance. It is the greater value one variable correspond to the greater value of the other variable, so that the holds the smaller variable tends to show the similar behavior. The covariance is true. When the greater value of the one variable tends to show opposite behavior, the covariance is negative. Thank you for watching this video. Have a good day. प्रैक्टिस करो, फॉर्मूले को कॉपी में लिखो, अपने आप याद हो जाएंगे, तब जाकर के आप इसमें अच्छा अपने परफॉर्मेंस दे पाएंगे. थैंक यू. हैव ए गुड डे. जय हिंद, जय भारत.